loop. Use a 10 times multiplier. That's the answer to that, to number 2. Okay?
10 times.
10 times multiplier. That's what we call this thing. It's wrapped around 10 loops of wire. Okay? To measure low amp ratings. 10 times multiplier. There you go. Keep going. Almost there. Spell that right?
Yeah, I know. That's good.
If you didn't spell it right, I'd take off all the points. Alright? 10 times molt. Molted. I don't know what that means, but anyways.
Molt's the same. Briefly.
Alright. Now, when you get done writing multiplier.
Did I spell it right?
Multiplier. That'll work. Alright, check it out, guys. Alright, this is the lab task. Alright, it says here, take the voltage readings from the following locations and components while the unit is on. Set the multimeter to voltage. Okay? Turn the power on to the unit. Okay. There we go. Alright, there we go. Now it's all balanced out. Now it says, measure the incoming voltage to 1 and 2. Power is coming in from the outlet. Coming all the way through, coming through here. Okay? We have lines 1, 2, and ground. So 1 is the power, the neutral is 2, and then we have our ground. Okay? So, what is the voltage between 1 and 2? Let's take a look. Looks like my battery's starting to go weak. Got the battery icon on. Okay?
My house already involved.
Go. Check it out. See? Alright. 1 and 2. What's my voltage? 121, right? Okay. Now.
Measure across the time delay control.
Okay. Now. I'm going to point out the components now. Okay? That's our time delay control. Alright, up here, guys. We've got our evaporator with an evaporator fan. Okay? We have our thermostat right here. We have our condenser right here with a fan on the back. Our low pressure cutout. Our high pressure cutout. Over here we have our low pressure cutout and our high pressure cutout over there. Different manufacturers does the same job. Okay? Compressor. Okay? Contactor. With a 24 volt coil on it. Time delay relay. 24 volts usually flows through those 2 points. Transformer. 120 volts, it says right here, that must be our primary side. There's 24 volts right here. That's our secondary side. Okay? Primary, secondary. And it says right there.
What does it say? This is the primary.
120 volts.
Secondary. Okay.
Yep. Okay? Our relay. Okay? Here's a switching relay. Here's the coil right here. We should have 24 volts on that coil. Okay? Now, we went over all the points. Okay? Now it says, measure the voltage across the contacts of the contact. Okay? So, we have 2 sets of contacts, 1 and 2. To go across the contacts, we're going to measure from here to here, or we can measure from here to here. How many volts do we see? 0.0. Okay? Always look for the decimal point, guys. 0.0. Oh, over here, listed here. Now, when you just erase that, read that, what does it say? Are the contactors open or closed? Are they? Closed or open?
Close.
Closed. Very good. Okay? Now watch, guys. Watch your contacts here, okay? They're closed. Take away the power.
Open.
The linkage released it, okay? The coil released it, and the linkage popped it back up. That's closed. Okay? Alright, now it says, measure the voltage across the switching relay. Okay? So, we measure our contacts over here. Okay? across the pressure control contacts, low pressure. And then we're going to go across the low pressure right here. And then it's going to ask you for the high pressure. Okay? Hopefully. Now, measure the voltage of the compressor common to run. Okay? Let's see. Well, I got my flashlight on, guys. Alright, now, and the reason why I picked this one because they're marked for us. Now, what we've got here, guys, we have our start, run, common. The reason why I know that is because there's an S here for start, R for run, and a C over here for common. If you notice, the blue wire is plugged into this device here. What is this device here, guys? That's the capacitor right there. Overload. Okay? Now if you notice, the common plugs into the overload, goes through the overload, and plugs into the C terminal. Okay? So that's how we have our overload in series with the start and the run, because this is the common side of the two. Okay? Now the question was, what was the question?
Measure the voltage from the compressor common to the run terminal.
Okay. Alright, now we're setting DAC. Check it out, guys. We'll go from run to common. And how many volts do I have?
120.
Okay, 120 volts.
To common.
How many volts do we have coming into the unit again, guys?
Okay, 121.
Okay, now what's the next question?
Why are we reading?
Because voltage is being applied to our run terminals. Okay? What's the next question?
Measure the voltage from the compressor common to the start terminal.
Alright, I want you guys to look at this. Okay, from start to common. What kind of voltage am I reading there?
150.
150. Alright? Now, if I have 120 volts coming into this, how in the hell am I getting 150 volts?
Is it the range?
No. Let me educate you about something real quick. We've got, technically we've got 3 windings. Okay? We have our run, our start, and our common. Okay? We have our run windings and start windings. Okay? Start windings and the run windings, once the unit comes on, the start windings and the run windings come on together. When a compressor comes on, the start windings drop out. The start windings are on there just to get the compressor to turn on, push the fluid, get the motor going, and also we have our start capacitor to help out. Because there's so much here, we have to get our motor to spin and turn on, plus we have to overcome the pressure from the refrigerant. So it has a lot of work to do to get started and to get going. Okay? It's like waking up in the morning with a bad hangover. Alright? You got a lot to get going here to get your body moving. Alright? So, since our start winding has dropped out, well, we're still reading 150 volts. Why are we getting 150 volts?
We're getting some juice from the capacitor.
The start capacitor actually drops out. You're close though.
You want all the windings in the motor, the copper wire that's all swung around, the motor.
You're very close. Mike Griffin.
Magnetic field.
You got it. Let me see. Hold on. Let me see. Alright. Now, what's happening here is the windings are close together. You got a start winding and run winding. Okay? So what's happening here is that we're getting residual back counter EMF is what's building up around the run windings and also spreading out to our start windings. Okay? Because we have another set of windings. It's actually building up a little bit of voltage there. Even though it's not being used, you can still actually read it. Okay? So actually it's like, in fact, you can write down if you want, it's residual voltage from the run windings. Or just write down residual voltage.
Residual voltage.
Residual power
Voltage. Or you can actually even write down back EMF from the run windings as that.
Voltage is being applied.
Applied to common.
Yeah. Now, the next question they're going to ask you is, what about start to run?
Measure the voltage from the
Start to run?
Well, it's already started, so we're gonna get nothing.
What am I reading?
0.
Ah, we
Oh,
got
3.
190, right? So,
It's 196.
so it's same answer. Residual or counter counter EMF.
Now, is there actually 196 volts though, or is it?
It's not being used. It's not being used in the system because
They're
there's
storing it.
well, it's just being created from the magnetic field.
Why is it?
Because the start windings are dropped out. Start windings are only in place for when they start. When the compressor starts. When it starts, it drops out just like that. I mean, it happens so fast, it's hard to see. Okay? Alright, any more questions about that?
No, we keep
Compressor.
going, you can just.
Contactor?
Contactor, time,
Relay?
relay, your step down transformer. It's a step down transformer, and that's your relay.
Yes. Yes, it is.
Contactor, time delay, transformer, relay.
What are those two components up there?
Low pressure switch, high pressure switch, evaporator, condenser. High side, low side.
Alright, that's good enough, good enough. Thermostat, TXV, blah blah blah, power switch. Alright. Alright, so you guys got the idea now?
Sure.
Okay. Now you're still gonna have to do all this. Now, next page. Measure the current of the following load level. Unit is on. Current means amps, right? Now, I don't want these. These things get in my way. Set it for amps on the amp clamp. Now it says to check the amp draw of between lines 1 and 2, right? Here's line 1, 8.4, line 2, 8.3, right?
You put that ridiculous kind.
Right here. Don't touch it, don't get electrocuted. Here's line 1, line 2, and ground.
Oh, it's saying,
Okay? So if it passes through the terminal block, here's line 1 and here's line 2 also. Okay? Alright. Measure the common compressor. That's the blue. That's what you're going to do there. Alright. Start winding was the yellow. Going to go right there. Run winding is to the pink. Okay? Coil of the contactor. There's the coil right there. Yep, yellow or the blue, I don't care. You're gonna get the same on both sides. Alright? Coil of the switching relay. Yellow. Or the blue.
Is it blue, yellow, pink, yellow or blue?
Transformer secondary winding. Okay, this is my secondary here. Or here. Yellow, red. Transformer secondary winding. Or primary. Okay, here's my primary. All you gotta do is just look at it, guys. This is 120, 24. Tells you right there. Alright? Now, we're pretty much done with the amps, right? Yeah, now we're going to do ohms. Make sure the power is off to the unit. Alright, move the leads back. Now, read to me what we have to do. Those 3 bullets right there.
Set the meter to ohms. Start with the highest setting.
Alright, we don't have to do that because it's auto-ranging.
Make sure to remove one wire when testing each individual component.
Very important, guys. You may want to underline that. It's in your notes. I had you write it down. We even had you do it in 103. Okay? Last 2 groups, I did it differently. I performed the lab task and I said, what am I doing wrong? Nobody can answer it. So, check it out. What's the first one we're going to do?
Measure the compressor run to common winding.
Okay, so what we're gonna do is we're gonna take one of the wires off. We're gonna take the run off. I don't care if you take the run or the common, it doesn't matter to me. So we're gonna go from run to common. Okay? We're gonna read about 1.4 amps. Okay? Then we're gonna do the start to common, start to run, and then you're gonna see a difference. Okay? Now, let's move on a little bit further here. Measure the coil of the contactor. Make sure you take one of the wires off, guys. Okay?
Which
And
is
then-
that one?
That's
The
the
one-
coil of the contactor. Okay? Here's our coil. So now we're going to measure our resistance here. Okay?
11.4, 11.5.
Yes.
Measure coil to contact.
Now,